it's extremely unpleasant what's happening to the planet. For instance, the big methane emissions that are going on from the Arctic seabed, they're occurring in the form of talics. That's a sort of a word for cracks in the seabed which are emitting methane. And they're all over the place, and people weren't aware of that when they started. Yet now, when you take all the methane together and it's the rate of loss, it's just huge.
Welcome to another Climate Emergency Forum program. Today we have a particularly important topic and an esteemed guest. Our topic is polar peril and the methane time bomb. This is of enormous significance, not just in the Arctic and the Antarctic, but throughout the planet. And I'm really delighted to be able to announce that we have with us today Professor Peter Wadhams. Peter, as many of you know, is a professor emeritus of ocean physics at Cambridge University. He is a sea ice specialist. In fact, you could probably say he is perhaps the leading sea ice specialist with around a half a century of research on sea ice and ocean processes in both the Arctic and the Antarctic. He's participated in more than 50 expeditions, that's right, 50, to both polar regions and has worked from ice camps, icebreakers, and aircraft. He's also traveled 6 times on the Royal Navy submarines under frozen North Polar sea ice to conduct research. And his very well-known and award-winning book is A Farewell to Ice, a report from the Arctic. So we're just thrilled to have you here, Peter. I'm Herb Simmons. I'm the author of A Climate Vocabulary of the Future. I'll be moderating today's session, which will also have our two regulars, Paul Beckwith and Peter Carter. But I don't want to take any more time away from turning it over to you, Peter, to tell us a bit about what in the world is going on at the poles and what does that mean for us and for methane. Peter, the floor is yours.
A while ago, people started to get concerned about methane being released from the polar regions. And the first work that was done was really by a Russian group with two people were leading it. They were finding that methane was being released from the seabed at many different levels. The amount was increasing all the time, and you were getting methane bursts, and it was becoming a more and more obvious component of the Arctic. People didn't initially think, well, much of it, well, that's just methane. But the more you looked at the methane, the more of it that seemed to be. And now when we look at methane concentrations in the Arctic, we're dealing with something which is as important as the more conventional components of the Arctic ice. Then to add insult to injury, there was just this week, there was a report of methane in the Antarctic being discovered in the area of the King George Island. And that is sort of a feeling of familiarity with King George Island, because it was the very first piece of the polar regions that I ever touched when I was a graduate student, and it was a voyage in a ship called the Hudson. We were going around South America. There was this wonderful island, which was my first landfall in the polar regions. And it turned out that it's now, thanks to some Spanish scientists, turned out to be an extremely potent source of methane. So methane is coming out of the Arctic and the Antarctic, which is part of the explanation for why there's so much of it. The levels of methane are rising And we're getting to be sort of concerned very much about this source. When we started to study it, it was coming out in terms of these small bubbles, not particularly weird, except that before long, people started to see that there were other sources in the Arctic which were rather more frightening. And one of them was actual explosions, which looked like gas explosions. Well, they are gas explosions, but not that kind of gas. And these were occurring throughout the Arctic, and we're seeing more of them all the time. So there's methane coming out in the form of explosions. There's methane coming out simply from the level ice in the Arctic. So the problem is how much of it is there? Is the amounts increasing so much rapidly that we have to really do something about it, or what? So that's, I think, what we ought to be discussing here and now, and I'm sure everybody has something to say about it.
Thank you, Peter. If I could just ask one question before I turn it over to Paul, and that is this discovery or analysis that methane is beginning to come out, or at least we're finding out that it's coming out of the Arctic, Antarctic rather, is this something new or was this something scientists were already anticipating or aware of?
I know the Antarctic finding is entirely new. In fact, the paper that showed the results was about last week, something like that. So it's an entirely new vision of yet another source of polar ice that we really have to worry about.
Oh, another unwelcome and unpleasant surprise.
Yes.
As if we don't have enough topics to discuss on the Climate Emergency Forum, we now have to add, sadly, methane eruptions or at least release from the Antarctic. So appreciate that information, and I'm sure we'll be able to post a link to that paper later on, so you'll be able to take a look at that. It's right off the presses, as Peter said. So let me turn now to Paul Beckwith. Paul, as I think most of you know, is a climate system scientist from Ottawa, and he has explored virtually every aspect of the climate crisis on his YouTube channel and on his website and another forum. We're here today to hear what your thoughts are. And we know, Paul, you've looked at this issue from so many different dimensions over the years. So please follow up on what Peter has said.
Thank you, Peter, and thank you, Herb. I just want to tilt my camera. Remember this, what happens in the Arctic doesn't stay in the Arctic. This saying I really like because, it talks about the Earth as a system and all the different components are connected. And when we get massive warming in the Arctic, also called polar temperature or Arctic temperature amplification, it affects the whole planet, the circulation of heat around the planet, the ocean currents, the atmospheric currents, the jet streams, which are slowing, getting wavier, getting stuck in place, leading to all these extreme weather events. And, part of the strong feedbacks or so-called tipping points in the climate system are, greatly warming Arctic, loss of huge ice melt, both from sea ice and glacier melt, therefore a real darkening of the surface, leading to more and more solar absorption and a spiraling feedback process where we get more and more melt. We tend to think of Antarctica as being somewhat isolated because ocean currents circumvent the whole continent, but we're seeing tremendous changes in Antarctica, especially in the last decade. Up until about 2015, sea ice around Antarctica was growing about 1.5% per decade. But since 2015, we've had a collapse of Antarctic sea ice. In fact, if you look at the total of sea ice from Antarctica and the Arctic, we're setting new record lows, it seems, every year. At the moment, we have a record low sea ice in the Arctic. It's dropped. The maximum extent was reached much earlier than normal. It would normally be around this equinox, which is coming up in a day or two, when we have sea ice maximum in the Arctic. This year it's happened much earlier, and we're getting steep drops right now, well below what is normal, setting new records by a long shot. So all of this, the methane, of course, as we greatly warm the poles, not just the Arctic, but Antarctica, then, through different mechanisms. In Antarctica, most of the warming is from seawater intrusion of warm water underneath the ice sheets and ice shelves, etc. And the island that Peter was talking about with the new paper, I'm not familiar with that paper, but I'll have a look. But I am familiar with some research that's been done recently in Svalbard on glaciers in Svalbard, and it's looked at meltwater coming out from underneath the glaciers, and the methane concentration is something like 800 times higher than you would expect. And then, of course, that methane gets dissociated into the atmosphere, equalizing and adding huge amounts of methane. And methane, of course, is a concern because on a 20-year time scale, the global warming potential relative to CO2 warming is about 86 times on a 20-year time scale. It's about 36 times on a 100-year time scale. But if you look at a few year time scale, then it's more like 150 to 200 times more potent. The WMO, World Meteorological Organization, just came out with a report yesterday, in fact, where they talk about they look at the greenhouse gas levels and the warming and all the so-called climate metrics, and they're all heading in the wrong direction. So, I try to always look at the big picture, look at the overall climate system, try to figure out the components, and, all signs are pointing to problems. Houston, we have a problem on this planet. So the Svalbard research was just one glacier that they looked at. They did kind of an assessment and said even just on the island of Svalbard, the archipelago of Svalbard, there's like something like that 1,500 or 2,000 glaciers. And, why would any of the other ones be different? They're all undergoing very rapid melt. So methane is becoming a problem. The big thing on Svalbard methane is that it's thermogenic methane. It's not biogenic. So it's not organic material under the ice that's thawing and melting, producing greenhouse gases like swampland is. It's actually thermogenic, so it's from the rock, it's from deep inside the earth itself. The reduction of ice in the glaciers, it lowers the pressure, pushing the ground down over long periods of time. We get isostatic rebound, but we're already getting cracks and fissures that are uncovered in the rock, which are releasing methane, which is getting into the meltwater. They can tell that it's thermogenic from looking at the isotopic signatures, doing isotope work on the carbon and oxygen in CO2.
Okay, thank you, Paul, for that important additional information. And I just want to stress what Paul mentioned, and that is, if you might be wondering, particularly if you're new to this, so what if methane is coming out? Well, as Paul said, methane has a global warming potential multiple times that of carbon dioxide, depending upon the time period that you analyze it. And there, I won't get into the reasons why the time period is relevant, except to say it's as much as 100 or 150 times more powerful per molecule, and thus the consequences for warming and all the other impacts from the climate crisis are accelerated the more methane gets from where it's been for centuries or millennia to the atmosphere. And that's something that we all need to be extremely concerned with and about. So with that, I'm happy to turn it over now to Peter Carter. Dr. Peter Carter is a retired medical doctor from British Columbia, the head of the Climate Emergency Institute, a reviewer, expert reviewer for the IPCC, and a longtime participant here at the Climate Emergency Forum. Welcome, Peter.
Thank you. And thank you, Peter Wadhams. It's great to see you again. Peter Wadhams has been one of the few experts and one of the few scientists who consistently has expressed his concern over methane, and quite rightly. Yeah, Arctic methane is increasing, and it's increasing, as Paul indicated, from all potential sources of methane in the Arctic. We keep on, or the scientists who do the research up there, seems like every couple of years they find another source. Most of the methane being emitted in the Arctic region, of course, is coming from the wetlands. Wetlands are fast responders to global warming, which is amplified in the Arctic. Permafrost, of course, has always been the huge concern, double all the carbon in the atmosphere. Permafrost is emitting all three greenhouse gases, all three main greenhouse gases. It's emitting methane, it's emitting CO2, a lot more CO2 than was ever anticipated, and it's also emitting nitrous oxide. So it's the Arctic is a greenhouse gas bomb, and if it hasn't gone off already, our governments and our corporations are making it go up. Because as James Hansen rightly advised us earlier this year, 1.5 degrees C, the globally disastrous limit, that's gone. And also now we are not able to limit to 2 degrees C, which ever since the mid-90s we've realized was a globally and planetary catastrophic temperature increase, particularly for the tipping points in the Arctic. Most of the planetary tipping points are Arctic. And it's worse than that because they interact. The scientists call it cascading feedbacks in the Arctic. So these several sources of methane hydrate, wetlands, and a peripheral glacier, as Paul mentioned, that's coming out, they're all emitting methane. And at 2 degrees C, all of the tipping points, this was published in 2018, really good paper, all of the tipping points are triggered. Now, the International Cryosphere Project earlier this year very rightly pointed out that we are in very big trouble with regards to our permafrost methane emissions because the permafrost is emitting methane. It's emitting a relatively small amount compared to our methane emissions, but it's feedback, you see. So once you've triggered feedback, it just increases, particularly if you're not reducing your greenhouse gas emissions. And of course, we're not doing that. And they pointed out that the methane coming from the permafrost at any particular time, it's irreversible. So it's irreversible now, the amount that's coming out. In 10 years, it'll be more and it'll be irreversible. And here's the terrible thing, which applies generally, but the cryosphere report did point this out, that what happens here is that we're leaving future generations with a massive amount of carbon to sink. And they worked out at 1.5, 2, and 2.5 how much it would be. I try and communicate about this. This is absolutely the worst criminal negligence that you could imagine. And our governments and corporations are continuing to extract more and more fossil fuels and to emit more. My last point is that I follow the methane, not from the IPCC, because this year, basically, there was no methane in the Arctic in the IPCC report, nor was there any Arctic feedbacks in the methane in the Arctic report from the IPCC. So I follow it from the Copernicus because the European Satellite Agency over many years has been refining the ability to see methane coming from the surface. Methane hydrate has, on this basis, has emitted on a very significant amount from the Kara Sea. The Kara Sea is well documented to have methane hydrate, which is vulnerable. And so having said that, so that's the worst, really the worst aspect of methane hydrate. And that'll continue to come out of the Kara Sea.
Thank you, Peter. Having been the moderator of these presentations for a few months now, whenever my turn comes after you finish, Peter, I always have to take a deep breath because you're always so clear, but always so bloody depressing. Not because you're saying anything other than what's factually true. It's difficult to hear all this as much as I have, and many of us hear this and study this and talk about this month after month and year after year. And I so appreciate that you're hanging in there, Peter, as are the rest of us, with talking about what are incredibly grim and dispiriting trends and phenomena. And just a couple quick comments, and then I'll turn it back to Peter Wadhams. I don't know that I heard the term before, greenhouse gas bomb. And having written a book on terms, I'm going to add that to my next edition of the book, because as you point out, it's more than just CO2, it's more than just methane, it's also nitrous oxide, and who knows what other rare or not so common gases may also be sprouting in the poles. You mentioned that essentially 1.5 is, if not in the rearview mirror, will be in the rearview mirror. Encourage folks to look at a recent program we did called Bye Bye 1.5. It's up there on YouTube and on the website to get a much deeper dive into that. And when you talk about what we're leaving for our future generations, there's so much emphasis in many countries on the financial debt. Oh, you're leaving a big debt and deficit, but that's just accounting, zeros and ones on ledgers somewhere. That could be wiped out tomorrow. That's not real. What is real is what some call the carbon debt, or maybe the greenhouse gas debt that we're leaving to future generations. That is very tangible, very real, and very, of course, destructive. Peter Wadhams, if I might, most of what we talk about here at our programs have to deal with, sort of just the facts, ma'am, talking about the science and what it means. But you have, I mean, using the word unique for your background in relationship to ice is totally appropriate, because you've been for decades, maybe no one on the planet more so than you have. You've been going back and back here and there in the polar and all the Antarctic and the Arctic, writing about it, thinking about it, seeing the changes from when you first started. You said your first ship as a graduate student. So my question to you is, if you could, if you're willing to, how does all this at this point in your life make you feel? What goes through your mind beyond the science, beyond everything you've written about and what we've talked about, in seeing and reading about the state of where we are now versus when you started your career?
Well, it's a big subject. Um, it's 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 the same as you're saying. It's extremely unpleasant what's happening to the planet. For instance, the big methane emissions that are going on from the Arctic seabed, they're occurring in the form of talics. That's a sort of a word for cracks in the seabed, that is, which are emitting methane. And they're all over the place, and people weren't aware of that when they started. Yet now, when you take all the methane together, and it's the rate of loss, it's just huge. And so it's depressing that that is something that wasn't really recognized. And as the colleague has said, that you didn't, nobody was saying anything about methane for a while, for a long while. And suddenly there it is. And you have to consider it. And it's when you look at the sources of methane, sources of greenhouse gases, methane is now up there with the leaders, which wasn't the case before. When we look at that and we recognize what's going on, we can't sort of find any good news anywhere. That's the problem that I have, because just looking at the very beginning of my career, when I was wandering around on this ship, the Hudson, which is Canadian, and the energy released by the sources there in the Arctic waters is much greater than I thought, and anybody thought. I remember doing lots of nice sketches of polar waters around King George Island and thinking, this is wonderful. But in fact, this water is full of emissions of methane, which are increasing the overall burden. So it's a horrible experience to see what's going on. There isn't a good way out that I can see. So,
Well, thank you. And I think the rest of us can only imagine what goes through your mind and those of your fellow colleagues who have been your research companions and collaborators over all these decades, and whose training is to be objective and cautious and not overstating the scientific creed. And then to see all this happening and to see the leaders on the planet in virtually every country ignoring, minimizing, denying, name your word, these phenomena that are going on is tough. That's all we can say. And I just personally want to add my thanks and appreciation for all you have done and are still doing and are still at it as you are here today, to speak out in the hope that there will be people in a position of authority and power who can still act even as time is running out. So thanks, Peter. Let me turn it back to Paul.
Yeah, thank you, Peter and Herb and the other Peter. There's definite changes in the Arctic topography and geography, geology, because of the greatly accelerated warming regarding methane, because we're getting, when we lose glaciers and ice, if there's organic material underneath that wasn't previously exposed to the atmosphere, it suddenly becomes exposed to the atmosphere. You can get biological decomposition. And if it's in water where there's a lack of oxygen, instead of getting methane, CO2 produced, you get methane produced. And of course, we're seeing many coastlines in Arctic and probably in Antarctic regions too being exposed with rising sea level and increased storm activity. That's exposing permafrost underneath the ground on these coastlines, and then suddenly that's exposed to very rapid melt rates with more methane coming up. We're seeing in Siberia, parts of the Siberian peninsulas, these new phenomena, these methane sinkholes or methane blowholes, where you get a large crater-like geographical feature. People have gone inside these and recorded very, very high levels of methane. So these things are all ongoing. A number of us are paying more attention to carbon dioxide removal from the atmosphere, but that would also include, or really should include, methane removal. The thing about methane is it's very short lifetime. Some people say as low as 9 years, other people 12 years. It really depends on the latitude. It depends on the sinks of methane, the OH radical in the atmosphere that can destroy methane. There's some people looking at ways to maybe put iron salt aerosols, for example, in the atmosphere where the methane can actively be reduced in concentration. But we need more and more research on all of these different ideas, because a lot of these ideas are very good, but are they scalable? Would they have a direct impact? And Herb can maybe talk to a bit more on some of those methods. We need to really talk about how we can restore a healthy planet, because as we further increase greenhouse gases and from emissions, we're actually having reduced sequestration or sinks on the planet. As the oceans stratify, there's less vertical mixing and fewer sequestration of carbon into the ocean sinks, and we don't have the luxury of time. Things have reached a very, very critical urgency. Nothing seems to be more urgent than the changes in the polar regions and the threats that those have to the stability of the Earth system. Of course, if the AMOC shuts down, then we don't have to worry so much about methane in the Arctic, because the parts of the Arctic will go into a deep freeze that could last for a century or two, certainly many decades. But then the Antarctic will overcompensate. And in terms of sea level rise, if the AMOC shuts down, sea level still rises rapidly because the melt rates from Antarctica greatly exceed that for, the reductions of what would happen in the Arctic from a cooling, the reductions from Greenland melt and so on. So there's lots of factors, lots of tipping points in the climate system that can really throw a wrench into things that we see in the near future with the climate system changes.
Okay, thank you, Paul. You mentioned a couple of potential techniques, and before I turn it over to Peter Carter, I just wanted to mention, there's nothing magic about a report or a study, but there's one report that was done, I think a year or two ago, that I think is significant in terms of laying out some possibilities. It's called, and I'll I'm sure we'll provide a link to it. I printed out the title here, Frozen Arctic. It says a horizon scan of interventions to slow down, halt, and reverse the effects of climate change in the Arctic and northern regions. Doesn't cover the Antarctic, which probably have a different, somewhat overlapping, but maybe a different set of techniques. And it's actually 61 different techniques have been identified by these researchers. And in this report, at least, they did an initial first cut kind of matrix analysis showing that, these are costly, these are uncertain, these have potential, these are on the sea, these are on the land, these are on the air, et cetera, et cetera. And it was produced importantly in the Arctic by the University of the Arctic and other collaborators. So it was folks who know the area the best. And I would recommend taking a look at that. I understand there'll be a follow-up to narrow down those techniques and go into them in more detail. But it shows with 61 potential interventions, there's lots of possibilities, but as we always say here, without emergency/urgent action, all the great possibilities mean nothing if they're done too late. And time is our biggest enemy. With that, let me turn it back to Peter Carter.
Okay, so I'll just point out then that we're tearing apart the planet, and that's absolutely terrifying. And the most terrifying region is absolutely, definitely the Arctic, because we have all of the tipping points and huge sources of amplifying feedbacks in the Arctic. They're all operant, and they've been operant for a number of years now. And of course, the scientists say that, as I said before, that the relative amount of carbon and methane that's coming out of the Arctic is small compared with our emissions. But as soon as we triggered permafrost emitting greenhouse gases, I mean, that was the call for a massive intervention, which of course has to include immediate decline of global emissions. Yeah, methane is increasing extremely fast. The highest methane on the planet is actually in northern Canada. It's in East Trout Lake, which is the southern border of the vast Canadian wetlands. That's one of the Hudson Bay wetlands, one of the largest in the world. Since 2016, that methane has absolutely been rocketing up faster than ever before and faster than anything else. It's reached 2,050 parts per billion. In 2007, 2008, it was 1,850, 1,850. In relatively few years, gone up to 2,050. Absolutely crazy, terrifying. I do agree with Paul. I mean, obviously, we've got to the stage when we have to have at least a capacity for intervention. The MIT reckons it'll take 30 years to be at a stage when we can remove any amount of CO2. Well, obviously, we've got to do it faster than that. So we should be experimenting with all of these things. I agree with the environmentalists years ago who said, no, we can't go there. But on the other hand, if we don't, we're dead, folks. We just can't allow this going on. So everybody's going to have to get shipshape and get on deck. And I'm worrying very much about this, as our friend Peter Wadhams has been doing, and he's absolutely right. Forget about the wars. Have a war on fossil fuels. Save planet Earth, for heaven's sake. Final point.
I could comment on that.
Please do, Peter.
Agree, absolutely, because the vital need of making this the top priority is a need to develop methods for removing carbon dioxide from the atmosphere in the most efficient way possible. And that's scarcely been touched. And on top of that, you now have active opposition, which is sort of bonkers because we don't know what might be the results. But of course, if we don't do anything, we won't see any results. In fact, we won't see any results for the human race. This bonkers thing about not daring to do anything is extremely dangerous. Well, it's just crazy. And so I think Peter's right in saying we're dealing with a crazy situation where what is actually needed is a total dedication to the cause of how do you remove carbon dioxide or how do you remove methane from the atmosphere. we have to do it, and we're not doing it, and we're even thinking of reasons why we shouldn't bother because it might be dangerous.
Yes, as I was saying before, scientists are usually cautious, and that's how the culture goes. And what we're hearing is some of the most esteemed scientists around on this program are using words like bonkers and crazy and we'll be all dead because you are speaking from your heart, interpreting the scientific data that you all have spent decades researching, examining, weighing, writing about. And this is your conclusion, that action is essential. Not that additional study wouldn't be helpful at the edges and the margins, but we're long past the point of saying, well, we're not sure, we're uncertain, let's take a little bit longer. What about the risks of this and that and the other? No one here is saying that interventions, whether it's directly cooling the planet, removing CO2, should be done on a haphazard basis or without as much informed knowledge as possible. But what I think we are saying is that we need to do that research and development as urgently as possible, the same way we do when we're fighting a war. This is a war for our survival as the human race and for every other species on the planet. So forgive my little mini rant, but basically both Peters have sort of brought that out in me as well. And I thank you for that. I want to say to those of you who are watching, we really appreciate you watching and being loyal followers and giving us your thoughtful comments or so. And as much as possible, we hope that you will look for ways to intervene. There are all sorts of ways, and we can talk about that in another time. But don't feel powerless, because powerless essentially guarantees failure. And the odds are long, but they're not zero. Let me see if Paul, if you have any additional thoughts you'd like to make.
Yeah, well, I've always recommended getting a kitten or a puppy, as a major antidote. I mean, we can't get depressed, right? We have to be able to function. We have to be able to be creative and have ideas. The crystal ball's opaque. It's even more opaque now with the new government in the US than it was before. I've come across a book recently, so I'm going to show it here. The Bright Side, How Optimists Change the World and How You Can Be One. And it's written in 2025. This author uses a lot of art and so on and has a lot of good ideas. This is why one of the reasons I talk about climate interventions, trying to stick up for the planet and trying to do maybe some interventions to buy us time to do these other things that we need to do, like reduce fossil fuel emissions. It's just not happening. Greenhouse gases are rising at accelerating rates. Herb's mentioned the word depression a few times, that, we have to fight against that. We do have agency. Things can change very quickly. Often it's darkest before the dawn. We have to care for our own sanity and mental health in order to be effective, to try to help. And we need to try to do things that are correct, we know are morally right. Whether or not there's an effective solution or not, we just don't know that. But that shouldn't stop us doing what we need to do on a day-to-day basis, one little part at a time. So anyway, thank you so much, Peter Wadhams, for coming on, and thank you, Herb and Peter Carter. And Herb, you probably have a lot of new terms you can put in the next edition of your book. And
Yes, I thank Peter Wadhams and all of you for that. I want to thank you so much, Peter Wadhams, for spending time with us, for sharing both your knowledge and your passion. Both are so essential and critical. As I said, we hope you'll come back again. Please, stay in touch with us. I know you're on the Healthy Planet Action Coalition lists and other lists. We so appreciate your involvement. We look for your leadership and your inspiration. And again, I think speaking for all of us, we're honored that you were here today. And we hope our viewers will, as always, like this program, subscribe to our channel, leave us your comments, share this program with your friends and colleagues, and go to our website, climateemergencyforum.org, and you will see a donate button there. And we survive and thrive based upon your support. And so if you can help out in any way, shape, or form, we would greatly appreciate it. So thanks to Paul, to Peter, and to Peter. and we will see you next week.